In this problem, we're told two objects attract each other with a gravitational force of magnitude 1 times 10 to the minus 8 newtons when separated by 20 centimeters. If the total mass of the objects is 5 kilograms, what is the mass of each? Right, so I just wrote down the information we're given. We're given that the gravitational force is 1 times 10 to the minus 8. We know the distance between the two, which we just write down as the radius, right, from the middles, right, is 20 centimeters. We know the total of their mass, right, so the mass total is 5 kilograms. And what we're trying to do is find the mass of each of them, right? So mass of each of the objects. And so I wrote m and m. So uppercase m is basically going to be the mass of the bigger object, and then lowercase m is going to be the mass of the smaller object, right? So what we want to do is find each of these. So how do we want to do that? So I'm going to go through and explain how we do it, and you'll see how we do it going along. But essentially what we're going to do is use the gravitational universal law of gravitation, which is this formula right here, which is F sub g, right, is equal to, so you should know this formula from the problems before, but F sub g is equal to g times m1 times m2 over r squared. So basically this is the gravitational force, right, which is what we're given this, right? G is called the gravitational constant, which is something you should memorize, right? It's just a number you need to know, which is just 6.67 times 10 to the minus 11, right? So yeah, that's going to be g, and then the units are Newton meter squared over kilogram squared. So you don't really need to know the units because they're going to cancel out, but just 6.67 times 10 to the minus 11, that's g. M1 and M2 are your two objects. So in this case, right, the mass of your two objects. So in this case, it's going to be m and uppercase m, right? So these two, right? So I'm actually going to write that out. Fg equals g times m and then m over r squared. So, and we know r, right, is just the distance between the two, the radius. And when we do this, it needs to be in meters. So it's just the same as 0.2 meters. Because there's 100 centimeters for every meter, but yeah, so 0.2. And so what we're going to do, right, is we know m, right, so uppercase m plus lowercase m is equal to 5, right? And so what we want to do is solve this for the little m. So if I minus the big M, right, because we don't know what they are, so we're just calling them arbitrary values for now. Basically, lowercase m is equal to 5 minus the larger mass, right? So the mass of the smaller object is 5 minus the mass of the bigger object. And you can imagine that, right? Because there's only two objects, so if you subtract one from the other, it's just going to be this one, right? And so since we know that, what we're going to do is solve this formula, and we're going to replace m with 5 minus m. But you'll see how we do it in a second. It's going to make it obvious why we solve it this way. But what we want to do is get it in terms of m and m. So if I multiply both sides by r squared, right? So if you go ahead and do that, and then what you want to do is go ahead and divide by g. So divide by g. So keep in mind I'm dividing by g, so you're just gonna have m, large M, right, uppercase, times m, and then you divide by g, and then you're just gonna have r squared times f sub g over g, right? So r squared times f, right, so the gravitational force divided by the gravitational constant, right? And so since we know this, right, what we want to do is solve for this side, right? So you say m times m, right? And so keep in mind what this is going to be in. These are this is mass and mass, so they're both kilograms. It's going to be kilograms squared. So we can solve for this number, right? This is r, we have f sub g, and we have g. So you can just solve for it by plugging it in, right? So I'm just going to write it here. So r is 0.2, so 0.2 squared times f sub g, 1 times 10 to the minus 8, right, divided by g, which is 6.67 times 10 to the minus 11, right? So you just want to plug in those numbers. So yeah, just go ahead and plug this in, and when you do it, you're going to get this whole side is equal to 6, which means m times m is equal to 6. And then the units are kilograms squared. So you don't really need to know that, but just know it equals 6, okay? And so what we want to do is, if I plug in m, right, which is 5 minus the large mass, right? So mass times 5 minus the large mass is equal to 6, right? And when I do this, this is going to be m times 5 is 5m, minus, and then m times m is m squared, so minus m squared is equal to 6. And what do you notice about this? You should notice that it's just a quadratic, like it's in quadratic form, right? So what we can do is use the quadratic formula to solve this. So yeah, you just want to manipulate this, right? So I'm just going to get it equal to 0. So I'm going to add this to the other side. So it just becomes m squared minus 5m, right? And then it's going to be, yeah, plus 6, right? So all this equals 0, right? So it's just in quadratic form. So you can use the quadratic formula you want to solve this, right? And so, yeah, so you can use the quadratic formula, or you can just graph it. I think the easiest way is to graph it. So what you're going to want to do is just go, right, plug in, go on your graphing calculator if you're allowed to use it, right? So it would just become x squared minus 5x. So just plug in for x, right? And then plus 6. And then when you graph it, right? So you want to graph it on your calculator. And then what you're going to get is two different numbers, right? So when you graph it, what you're doing is looking for where it crosses to 0. That's basically what the quadratic formula is, because we're solving for m. And you're going to get two different values. So you're going to get m can be equal to, right? So you can either get m equals 2, right? Or you get m equals 3. So basically there's two values you get, but let's think about that, right? So when you graph it on your calculator or you solve it through the quadratic formula, you're going to get it equals to 2 or 3, okay? So because when you solve it with the quadratic formula, I'm not going to do it, but I'll just tell you what you get. You basically get 5 plus or minus 1 over 2, right? So 5 plus or minus 1, that could be 6 or it could be 4, right? And then you're dividing them by 2, so it's either 3 or 2, okay? And that's what we got here, right? I think the easiest way is to graph it. That's generally how I solve these, just because you don't have to go through the work, but just keep that in mind. So m is going to be equal to 2 or 3, right? But let's think about how this works. If m is 2, right, and we know this is the bigger mass, if we do m equals 5 minus uppercase m, this is going to be 3. But what do we know about m? M was denoted as the smaller one, meaning it can't be 3, right? Because it's greater than m, which is bigger. So that doesn't make sense, right? So it has to be the 3, right? Because if we do m equals 5 minus 3, it would be equal to 2, which does make sense, right? It's smaller than uppercase m. So what does that tell us? It has to be equal to 3. So that means uppercase m, right? So the mass of, or the mass of the larger object is going to be 3. And then the mass of the smaller object is just 5 minus 3, which is 2. So 3 kilograms and 2 kilograms. Right, so these are going to be the two objects, right? So the bigger mass, or the bigger object, or one with the greater mass, right, is just 3 kilograms, and the one with the smaller mass is 2 kilograms. So these are going to be your two answers. But yeah, these are your answers, and hopefully you found this useful.